Hello students, today I will discuss power of a lens. What do you mean by power of a lens? Now, power of a lens is the ability of the lens to converge or diverge a beam of light. Means how much light it can bend. Suppose there are two lenses, okay? Light incident on this lens, okay, the distance is equal, this distance and this distance equal distance. Now so if this is x, then this is also x, equal distance. Now the lens converges the beam, bends, it will not go straight, light will not go straight, okay, it will not go straight, it will bend towards the this principal axis like this, you know. No, now you see, bending may not be same in two lenses. Suppose here bending is more and here bending is less. Okay, here the bending is less. Both the ray bends, but here the bending is less, here the bending is more bending. Okay, so we call here the power is more, here the power is less. Okay. Now what is this distance? This distance is called the focal length f. This is called focus. So this is called focus. So this distance is called the focal length. Fine. This is focus. So this distance is called the focal length. Here bending is more, so power is more. Focal length is less. Here bending is less, so power is less. So focal length is more. So we have found a relation that P and F, they are inversely proportional. Okay, when focal length is less, power is more. When focal length is more, power is less. Now how to define power of a lens? The simple way of defining power of a lens is this. Suppose this distance, let us call this as h. This distance, let us call this as h. Okay, the distance of the incident ray from the optical center, let us call this distance as h. This angle is supposed del, so this is also del. Okay, then what is tan del? Tan del equals to perpendicular by base. So perpendicular is h, base is f, so h by f. If h we take as 1, then tan del become 1 by f. If h equals to 1, then tan del will be what? 1 by f. And what is 1 by f? 1 by f is called the power. 1 by f is the power. So how to define power? Power of a lens may be defined as, how may be defined as what? Tangent of the angle. Tangent, tan del, tan tangent, del means angle. Which angle? By which it converges or diverges a beam of light. So power of a lens may be defined as what? The tangent of the angle, tan del, car angle by which converges or diverges a beam of light. So in this case converges. It's the angle through which light is converges. It is the angle through which light is converges. So this is del. Del is the angle by which it is converges, and we have to take tangent of del. Tangent of del. Now converges a beam of light. Now which light? Which light? Light which is falling at a unit distance from the optical center. Now the distance of the light from the optical center, this distance we take this as 1. The distance of the light from the optical center is 1. Okay, so unit distance from the optical center. Light, a beam of light falling at unit distance from the optical center. This is a beam of light falling at unit distance from the optical center. Now this light is converges by this lens. The angle through which it is converges is del. Then you take tan of del, and tan del is called the power of a lens. So power of a lens may be defined as the tangent of the angle by which it converges or diverges a beam of light falling at a unit distance from the optical center. Power may also be defined as the what? Power may also be defined as the 1 by f. What is 1 by f? Reciprocal of the focal length. Thus, power may also be defined as the reciprocal of the focal length, that is P equals to 1 by f. Now, what is the SI unit of power? The SI unit of power is diopter. The SI unit of power is diopter, denoted by D. Now we will define one diopter. One diopter may be defined like this. If F equals to 1 meter, then what is P? Substitute the value of P. Substitute it here. P equals to 1 by F. Now F is 1, so 1 by 1 is 1. So 1 diopter. Thus, power is said to be 1 diopter when the focal length is 1 meter. Thus power of a lens of focal length 1 meter is called 1 diopter. For converging lens, what is F? For converging lens, F is positive. Therefore, power is P equals to 1 by F. F is positive, so power is positive. For diverging lens, you see F is negative. For diverging lens, F is negative. Therefore, power P equals to 1 by F. F is negative, so power is also negative. Thus, power is positive for converging lens and power is negative for diverging lens. Thank you very much.